Food coloring can be used to can be oxidized by household bleach, which contains which is hypochlorite, right, to form colorless products as represented by the equation below. A student used a spectrophotometer, parenthesis, because her school had one, close parenthesis, set at a wavelength of 635 nanometers to study the absorbance of food coloring over time during the bleaching process. In the study, bleach is present in large excess, so that the concentration of hypochlorite is essentially constant throughout the reaction. The student used data from the study to generate the graphs below. How nice that her school owned one of those. Based on the graph above, what is the order of the reaction with respect to the blue food coloring? Okay, the reaction is known to be first order with respect to bleach, but that's not what the question was asking. It was asking with respect to the hypochlorite, just so we're clear, okay? In the second experiment, the student prepares, so first order with respect to bleach. In the second experiment, the student prepares solutions of food coloring and bleach with concentrations that differ from those in the first experiment. When the solutions are combined, the student observes that the reaction mixture reaches an absorbance near zero too rapidly. In order to correct the problem, the student proposes 3 possible modifications: increasing the temperature, increasing the concentration of the food coloring, increasing the concentration of the bleach. Circle the one proposed modification above that could correct the problem and explain how, before you do anything, explain how that modification increases the time for the reaction mixture to reach an absorbance near zero. Here is the equation. Blue food dye, okay, and the bleach. It's first order, right, with reaction to bleach, and you just determined the reaction with regard to the bleach is present in large excess, so that the concentration of hypochlorite is essentially constant throughout the reaction the student used to generate, right? And you just determined the order relative to the food dye. Which of the following will explain how the modification increases the time for the reaction mixture to reach an absorbance near zero? It's reached, all right? You want to increase how that modifies the increase. Circle one proposed modification above that could correct the problem. And the problem is, I know you're not reading this, so I'm trying to read what you need to know. The student observes that the reaction mixture, look at the graphs, the reaction mixture reaches an absorbance near zero too rapidly. So which one is reaching an absorbance near zero? This one, right? I mean, or this one, I guess, but this is the ln of absorbance, right? So it's actually this one, reaching an absorbance. Does everybody see that? Okay, all right. So in order, and it's reaching it too rapidly. So they want to slow it down, right? So in order to correct the problem, the student proposes the following 3 possible modifications: increase the temperature, increasing the concentration of the food coloring, or increasing the concentration of the bleach. The reaction is known to be first order with respect to the bleach. In a second experiment, the student prepares the solutions of food coloring and bleach with concentrations that differ from those used in the first experiment. And when the solutions are combined, the student observes that the reaction mixture reaches an absorbent near zero too rapidly. Now, this is the first. In the study, bleach is present in large excess, so that the concentration is essentially constant throughout the reaction because it's excess. But the reaction is known to be first order with respect to the bleach. In another experiment, the student wishes to study the oxidation of red food coloring with the bleach. How would the student need to modify the original experimental procedure to determine the order of the reaction with respect to the food coloring? So that's an essay, so we don't want to do that one. Okay, you ready? So first, I'm hoping that you got that it is a first order reaction, right? Okay. The next question, question 5. Question 5. Okay, increasing the food coloring, right? Because there's an excess of bleach. So that means that any curve in the graph was created by the food coloring. Because there's so much bleach that it's available, it doesn't matter that it's first order, there's so much bleach that it's available in excess, so it doesn't matter. That's what they said. So the only thing that you could do to slow it down would be to increase the food coloring, the concentration of the food coloring. Does that make sense? Okay? The initial concentration of the blue food coloring is increased, then more time is required, regardless of the reaction order indicated for part A, for the bleach to oxidize the additional food coloring. Because you made more work for the same amount of bleach, which is excess, but it's going to take longer for that food coloring to be oxidized. Okay, let's see. Next one. All right, one more test to look at. Okay, here we go. The O3 molecule has a central oxygen atom bonded to two outer oxygen atoms that are not bonded to one another. In the box, draw a Lewis dot electron dot structure of the O3 molecule. Include all the valence-valent resonance structure. The ozone molecule has a central oxygen atom bonded to two outer oxygen atoms that are not bonded to one another. In the box below, draw the Lewis dot diagram of the ozone molecule and include all the valence resonance structures. Okay, next, you ready? So that's going to look like this, right? Because you're going to have the hybridization, right? Okay, all right, next. Based on the diagram you drew, what is the shape of the ozone molecule? This is going to be bent. Yep, all right? Okay, so we'll talk more about that. Like we're going to review those. Okay, next. A solution is paired, the data plotted below. So this shows what order does this show? This is a first order decay reaction. Do you see this? This is what you plotted with the pennies, right? Okay. All right, no homework over the weekend. We'll talk more on Monday. Put them in the box, please. Thank you. So this was using the equation, using the equation, ln of a to the t over a, the original concentration is negative kt. In theory, what would this be? So you're going to start out with your starting amount, your original amount. You look at your time, 51 seconds. You have your K that you calculated, and then what would your amount be at 50 seconds?